Hello everyone, I'm Logan. This is Steven,
Hello.
and today we'll be presenting a research focused on natural language processing, specifically how different NLU platforms perform when used in software engineering chatbots. The paper we chose is a comparison of natural language understanding platforms for chatbots in software engineering. This was published in 2021. And we chose this article because it gives a head-to-head comparison of major NLU tools, something developers and researchers often struggle to find. Throughout this presentation, we will break down the motivation, the methods, and key takeaways from their studies, and then tie everything back to why it matters for modern NLP applications. So, research context, the challenge. Developers need chatbots to interact with development tools and services using natural language, but selecting an appropriate NLU platform remains difficult due to the lack of empirical comparison in the SE domain. So then that begs the research question, which is which NLU platform performs the best for software engineering chatbots across intent classification, confidence scoring, and entity extraction. In this research paper, they evaluated the platforms IBM Watson, Google Dialogflow, Microsoft Lewis, and Rasa. Chatbots are becoming more common in software engineering, so they let developers ask questions in plain English instead of complex commands. The brain of any chatbot is the natural language understanding component. That's what turns human words into actionable meaning. But picking the right NLU for a chatbot is still hard, and these tools vary a lot in how they perform. So, methodology. There's two data sets. You have the repository task, queries about software repositories, and then Stack Overflow task, development Q&A forum questions. You also have the evaluation metrics, intent classification, confidence scores, and entity extraction. So the authors ask which NLU platform works the best for software engineering chatbots, and then they compare the four major platforms listed in the previous slide, and then evaluate them on the three things, which is how well they classify intents, which is what the user wants, and then there's how stable or trustworthy their confidence scores are, and how well they extract entities or key pieces of information. So, first result is the intent classification performance. As you can see, they found that IBM Watson achieved the highest F1 measures, which is the harmonic mean of precision and recall, and that was across both tasks, which is repository and Stack Overflow. This demonstrates consistent intent classification accuracy, and Lewis was the worst by far in repository and still came in last for Stack Overflow. So to test these NLUs, the paper used two real-world tasks in software engineering. For the repository tasks, questions about software code, for example, which commit fixed this bug, right? And then Stack Overflow would be questions from Q&A forums developers ask, such as how do I convert this in Java? The idea is to show how NLUs work on real developer queries, not just toy examples. And then for result two, the confidence score stability, they compared all of them again and found the winner for this was Rasa with a 0.91 median confidence score. All NLUs except Dialogflow provided trustworthy confidence scores, higher scores for correct predictions, lower scores for incorrect ones. Rasa maintained high performance with an F1 of greater than 0.7, a confidence threshold from 0 to 0.7, and while Watson and Dialog degraded above 0.3. So IBM Watson is a commercial cloud-based NLU from IBM, as we know, and then Dialogflow is Google's version of the NLU, supports different languages and integrations. Rasa is an open source NLU that you can deploy locally on your machine. And then Lewis is Microsoft's version. It's a cloud-based NLP service. So each one has pros and cons, cost, ease of setup, deployment, training data. But the paper focuses on their accuracy and reliability in the SE domain.
So for result number 3, which was the entity extraction performance, as you see on the graph, Lewis performed quite well in the repository, but fell off for the Stack Overflow, where IBM Watson did much better. So the challenge was to extract unseen entities. They found it was significantly harder. There was a decent performance drop in those entities. For the intents classification, they trained each NLU on training data, and then they tested them with unseen queries. And then they measured precision, recall, and their F1 scores. And then for confidence scores, they looked at whether high confidence meant correct classification and low confidence meaning wrong classification. And that mattered for deciding when a chatbot should say, I'm not sure, or give an answer if they know it. For entity extraction, they evaluated how well the NLU pulled out the key entities like file names, ticket numbers, stuff like that with an exact match. So factors affecting the NLU performance was limited training data, ambiguous vocabulary, and unique technical terms. Training data offered intents with fewer training examples showed significantly lower F1 measures. NLUs struggled when trained on sparse data sets, particularly with domain-specific terminology. With ambiguous vocabulary, words appearing across multiple intents caused confusion. Queries containing terms that map to several different intents reduced classification accuracy significantly. And then with the unique technical terms, there was an intent-specific technical keywords that didn't appear elsewhere, but they posed extraction challenges. Novel terminology unique to software engineering contexts was particularly difficult, with an analysis based on manual inspection of queries with an F1 measure of less than 60%. So the recommendations for practitioners was to increase training diversity, to provide diverse training examples across all intents to improve robustness, aim for better representation to prevent bias towards frequently occurring patterns, consolidate similar intents, to merge intents with overlapping vocabulary to reduce ambiguity. Also to include unique keywords, to incorporate intent-specific technical terms in training queries to improve classifications. And the last would be to select task-appropriate features by using list features for closed domain entity extractions with known values. And so the study limitations and context in these NLUs was limited scope. The studies focused exclusively on software engineering chatbots. Performance may differ in other domains with different vocabulary patterns and intent structures. There was static evaluation with data sets representing fixed snapshots of SE tasks. Real-world chatbot performance depends on continuous learning, user feedback loops, and domain adaptation over time. And then the last would be cost and accessibility. Study doesn't address pricing models or vendor lock-in concerns, such as RASA's open source nature, offering a lot more flexibility versus other closed platforms. In conclusion was that there was no universal winner. Each platform excelled in its own, in different aspects. RASA offered better confidence scores. Lewis led in entity extraction. And task-specific selection, platform choices should align with chatbot requirements, intent accuracy versus confidence reliability versus entity handling. And the broader implications of SE chatbot success depending on careful training data curation, intent design, and understanding platform-specific strengths. And you should consider modern alternatives like large learning machine-based approaches for current implementations. That's